Hey guys, this little piece is for the people who needed some help with the example questions on the normal distribution problems. So example 1 says, consider the heights of people with a mean of 181 centimeters and a standard deviation of 4 centimeters. Find the probability. Okay, so if we're finding the probability, he's definitely going to be an unknown area. When we have an unknown area, remember that we are going to be using the normal CDF function of our calculator. And we are finding the probability of a random person being over 186 centimeters. So I gave you guys the drawing of this already, right? If you were to sketch this by hand, you would have drawn a little normal distribution curve. You would have put a little line on the bottom. You would have put the mean in as 181. You would have put the standard deviation off to the side as 4, and then you would have found the x value of 186, and you would have shaded the area to the right. That unknown area is the area that we are trying to find, okay? So when we're doing normal CDF in our calculator, what we're going to want to do is menu 5 for distributions, and we go to 2 for normal CDF. Now, the lower bound of our picture says that 186 is our lower bound. And then the upper bound here is going to be infinity. And the reason why it's positive infinity is because the normal distribution curve is asymptotic with the x-axis. So it continues on forever in the positive direction and in the negative direction. Okay? So the way we would put positive infinity is in our calculator is we would do 186, and then you do 9 times e to the 99, or like it would really be like this if you were doing it in like scientific notation, but your calculator abbreviates it as e. Just know that on the IB exam, you can't write e. You have to write like proper scientific notation if you're like using it for something. So we have 9 times e to the 99. He's our upper bound because he's going towards infinity. The mean is given as 181. The standard deviation is given as 4. I hit OK. The probability that we're looking for is 0.10565. I'm going to round that to 3 sig figs. And here we go. That is the probability of a random person being over 186 centimeters. And the way you would write that is x is greater than 186. Okay, let's do number 2. Same info, but 70% of people are taller than x. So we're going to put that information on our thing here. X is an unknown x value. We know that 70% of people are taller than that. So we would like write a 0.7 to the right of that value and shade it in. And we are going to want to find x. So if we are finding an unknown data point here, but we have a known area, remember known area is going to be inverse norm, and you can remember that with known and norm. So we're going to be using the inverse norm function on our calculator. It's going to ask you the area from the left. So they gave us the area from the right, so we're going to have to do 1 minus 0.7 to get that area to the left, because remember, the cumulative area from the right is that probability that we are generating here. So we have menu 5, 5, 3 for inverse norm. Our area to the left is 0.3. Our mean is the same as above, 181. And then our standard deviation is 4. You hit OK. So let's write down what we put in our calculator. Make sure you write down what you put in your calculator, because let's say you're taking an exam and I see that you put everything in except for maybe the mean or something. I can still give you partial credit. If you just write down the wrong answer right here, I'm not going to be able to give you any partial credit because I don't really know what you did. So our x is going to be approximately 179 centimeters, because we rounded to 3 sig figs. Let's go to example 3. Example 3, the picture got kind of sent down here for part B. Just FYI, it got sent to the next page. Lo siento. Okay, let's read it. Heights of a group of 7-year-old children are with a mean of 117 centimeters and a standard deviation of 5 centimeters. So I'll just put the standard deviation over here. A child is chosen at random. Find the probability that the child is taller than 122.5 centimeters. So this is an X value. He's going to go on the X axis. I'm going to put a little line where he occurred and then shade up. That is the probability that we are trying to find. Remember, if we're finding a probability, our area is unknown. That means we're going to be using the normal CDF function. So the probability that a child or an X data point, aka a child, is greater than 122.5 centimeters is going to be found with normal CDF. I have my menu 552. My lower bound has 122.5. My upper bound is infinity. My mean is 117 and my standard deviation is 5. So we are typing all that in. We have 122.5, infinity, 117 and 5. And we would get 0.135666. I'm going to round the probability that a child is taller than 122.5 centimeters to 3 sig figs, 0.136. That's our probability. Okay. Let's do the next part here. Okay. The probability that the height of a child is K is 0.65. The mean is 117 and the standard deviation is still 5. Find K. So the picture for this guy is down here. Sorry, follow me to this spot. Actually, this is good practice. You can draw this yourself. Instead of using the picture that I gave you, why don't we try to draw this ourselves? I like this. Let's draw it ourselves. So we have our standard bell curve. We have our mean of 117. There's some height K where 65% of the kids are less than that height. So I'm just going to put that in here. Okay. Our standard deviation is 5, and I think I got everything on here. Great. Okay. So we are trying to find K. That means our area is known. We use inverse norm. Our area is 0.65. They gave it to us from the left, so we're good. The mean is 117, and the standard deviation is 5. So I've got 118.927. So K is approximately 119 centimeters. Hooray!